Today on Milanese Math, we're solving multi-step equations, so buckle your seatbelt. Okay, so multi-step equations can sometimes get a little bit intense. We're only going to do 2 examples in this tutorial because sometimes they take a little bit of time. But if you follow these steps, you should be able to get the right answer every time. So the first thing I like to do is draw my line down the equal sign. Now, anytime you have a multi-step equation, there's going to be multiple steps. The first one I always look for is, I ask myself, is there anywhere I can use the distributive property? And this equation actually has 2 places. On the left-hand side, we're going to distribute a 9, and on the right-hand side, we're going to distribute a 3. So let's go ahead and do that as our first step, and we'll see where that puts us. 9 times 11 is 99, and 9 times negative k is negative 9k. Okay, so let's do the same thing on the right-hand side. 3 times 3k is 9k, and 3 times negative 9 is negative 27. Okay, so we've done with the distributive property. Now I want to check and see if there are like terms, anything that I can combine on the same side of the equal sign. So if I look to the left, 99, negative 9k, those are not like terms. And 9k and negative 27 aren't like terms either, so I can kind of skip that step. The next thing I want to look is to see if I have variables on both sides, and I do. In this example, I've got negative 9k on the left, positive 9k on the right. Well, to solve that problem, we have to get all of the k's either to the left or the right. And it really doesn't matter, but for me, I always choose the side that has the bigger coefficient. So if we compare negative 9k and positive 9k, positive 9 is a bigger number, so I'm going to go to the right-hand side. That means I want to get rid of the variables on the left-hand side. So I want to get rid of negative 9k. I can do that using inverse operations. So I'm going to add 9k to both sides of the equal sign, and we'll see what that does. We can go ahead and drop down 99 to the next line, and our 9k's cancel out. This equals 9k plus 9k is 18k, and I can drop down the minus 27. Okay, so we're almost there, 2 steps left. The next step is to look for constants. Are there any numbers by themselves that I can get rid of? In this example, a negative 27. So I can undo a negative 27 with a positive 27, and of course I have to do that to both sides. So let's see what that gives us. 99 plus 27 is 126. Can drop down the 18k since nothing has happened with it, and our 27's cancel. Okay, final step and then we're done. This is 18 times k. I can divide by 18, and that should be it. 126 divided by 18 is 7, and 18 divided by 18 cancels, so now we have a final answer of 7 equals k. Okay, so for this last example, we're going to look at an equation that has just about everything going on. This says negative 5 minus the quantity 15y minus 1 equals 2 times the quantity 7y minus 16, subtract y. There's a lot going on, and if you follow these steps, you should be able to get it right every time. So the first step is look to see if you can use the distributive property, and there's a couple places in this problem. On the left-hand side, there's really a negative 1 out in front that's going to distribute in. This negative sign distributes in. And on the right-hand side, we have a 2 that distributes in. Okay, so before we do anything else, always take care of the distributive property first. So the negative 5, nothing has happened with it. When a negative 1 distributes, it just changes the sign. So this used to be a positive 15y, now it's a negative 15y. Negative 1 times negative 1, we'll turn that into a positive 1. So I've rewritten the left-hand side after I've done the distributive property. Let's do the same thing on the right. 2 times 7y is going to give me 14y, and 2 times negative 16 gives me negative 32. Don't forget about this subtract y at the end of the problem. Okay, you're done with the distributive property. The next step is to look at both sides of the equal sign and see if you have any like terms that you can combine. And again, we've got a couple places where that needs to take place. So if we look at the left-hand side, I notice that I have some constants that I can combine, some regular numbers, negative 5 and plus 1. If we take negative 5 plus 1, we get negative 4. So we're going to combine our like terms, and get negative 4. Don't forget there's still a minus 15y. But how about the right-hand side? Are there any places on the right-hand side where we can combine like terms? Well, once again, we've got a 14y and a minus 1y, and we can combine those since those are like terms. So 14y subtract 1y is going to give me 13y, and drop down your constant of negative 32. So again, all I've done is combine like terms. Okay, distributive property, combine like terms. The next thing is to check and see if you have variables on both sides, which once again, this problem has that going on. I've got a negative 15y on the left and a 13y on the right. For me, I always go to the side that has the bigger coefficient. Be careful though, negative 15, positive 13. Positive 13 is the bigger coefficient. So I'm going to go to the right-hand side, which means I want to get rid of the variables on the left. So inverse operations, I can undo a minus 15y with a plus 15y. And when I do that on the right-hand side, when I add 15y, I'm going to go ahead and stack it underneath the like term. I wouldn't stack it underneath a negative 32 because those aren't like terms. You can't add them, but you can definitely add these two. Okay, so let's update the equation and see where we're at. On the left-hand side, if we go left to right, we've got negative 4, and these terms cross out. Equals 13y plus 15y is 28y, and we still have this negative 32 hanging out here on the end. Now, this looks a lot more manageable. We're almost there. After you've done the distributive property and you've combined like terms and you've got all the variables to one side, then just start solving like a regular equation. Look for constants, get rid of them. If I look at the right-hand side, I see a negative 32. I can undo that with a positive 32. I'm going to do that on both sides. And negative 4 plus 32 is 28. And since these terms cross out, all I have is a 28y on the right. And hopefully you can see how we're going to finish this. Our last step is to get rid of our coefficient, which in this example is a 28. That's 28 times y. Inverse operations says divide by 28. So as a final answer, 28 divided by 28 is 1. And since these cross out, that is going to be our final answer. So there's a lot to keep track of. To review, look for the distributive property. Look to see if you can combine like terms. Then see if you have variables on both sides. Then see if you have any constants to get rid of. And finally, typically you divide by it or multiply by your coefficient to get rid of it. So that is a little bit about how to solve multi-step equations.